everyone, welcome back to Epsilon Academy. I am Arjun and today we are diving into something incredible, exciting and valuable for all of you, aspiring data scientists and machine learning engineers and AI enthusiasts. We are going to tackle 100 machine learning and deep learning interview questions and answers that will not only boost your confidence but also help you in next interview. Whether you are beginner or experienced, this video will take your knowledge to the next level. So grab a notebook and sit back. Let's get started. If you wanted to take this PPT, you can comment in the comment box. I will pin a link in the comment box. So in this video, we just covered the 100 machine learning and deep learning questions related to the supervised ensemble or deep learning algorithm. So let's get started with the supervised learning algorithm. So in this video, we just give you the perspective how you can tackle the 100 machine learning or deep learning questions in a one line. So this is the quick revision, you can say like that. This is not the a detailed video about the algorithm. So after that, after covering the 100 machine learning deep learning question, we will just cover the quick revision of all those things. And after that, we will explain everything in detail. So let's get started with the first question. So first question is, what is the linear regression? So simple one line answer is a method to predict continuous dependent variable based on the value of independent variable. Means we have a continuous dependent variable and there with respect to continuous dependent variable, we have some other independent variable. So we just want to predict the continuous dependent variable. This is the simple linear regression definition. Next question is, what is the primary objective of linear regression? So what is the primary objective of linear regression? We just want to fit a single line and after that we just want to minimize the sum of residuals. So this is the primary objective, to minimize the sum of square of residual. Next question is, what is the assumption of linear regression? So before applying the linear regression, we have to think about the some assumption when we can apply the linear regression. So first assumption is linearity. So what is the meaning of linearity, independence, homodensity and normal of residual? So basically linearity means the relationship between the dependent and independent variable is linear. And the independence means observation are independent to each other, means every feature are independent to each other. And next is the homoscedasticity. So basically homoscedasticity means the variation of error is constant, means if we find out the error variation, that it should be constant. And next is normality of residual. So basically normality of residual means the residual means error. So error of model are normally distributed, not any other distribution it will follow. So it will follow normal distribution. So this is the linear regression. And next, what is the logistic regression used for? So logistic regression is used for only binary class classification because it will just provide you two values. So for example, when we can use like email class classifier and disease prediction for disease, there is disease yes or no. So like that. What next question is, what function does logistic regression use to model the probability? So logistic regression, in the logistic regression, the model is used like a sigmoid function. And next question is, how do you evaluate a logistic regression model? So evaluating the logistic regression, we use model metrics like accuracy, precision, recall, F1 score, AUC, RUC. So that's the metrics we use. Accuracy we can use if the classes is equally distributed. If classes is not equally distributed, then we go for like F1 score or AUC, RUC. If we just want to predict that disease is not yes or no. So in this in this type, the data is imbalanced because we have the more data in disease is no, or we have less data for diseases is yes. So that's the thing when we that doesn't use accuracy. And like that terrorist prediction. So in the general human, terrorist is less in the count. So that's why we not go with the accuracy. So let's go with the next question. And for the linear regression model, which method to evaluate the linear regression, we can use R2 score or RMSE. Next question is, what is the decision tree? So decision tree basically a tree-like model of decisions, a tree-like model of decision and their possible consequences, means every split, so their possible consequences. So this is the basic meaning of decision tree. And next question is, how do you prevent overfitting in decision tree? So preventing of overfitting in decision tree by pruning. Pruning means you can reduce the number of trees and setting the maximum depth and require a minimum number of sample per leaf. So this is the idea for pruning decision tree, preventing. And next question is, what is the random forest? So random forest is the assemble method using multiple decision tree to improve the accuracy. Instead of using single decision tree, you are using here multiple decision tree. For random forest, you just make the bootstrap sampling. Bootstrap sampling means you randomly select the data and after that just predict the multiple decision tree and take the average in the sense of regression problem and take the mode of classification problem. Next question is, how does random forest handling overfitting? By averaging multiple tree, reducing model variance. How does random forest handle overfitting? By averaging multiple tree, reducing model variance. Already I told you. Next question is, what is the main hyperparameter in random forest? So number of tree in the forest. So number of tree in the forest is main hyperparameter. Also, instead of using decision tree, you can use different type of model here, like SVM in the decision random forest instead of using tree. all these are things are possible. So next question is, what is the support vector machine? This is a very good algorithm. So an algorithm that find the hyperplane that best separate different classes. Means if you have two classes or three classes, so you just want to the best hyperplane that will separate best separate the classes. Next question is, what are the kernel function in SVM? So kernel function are different type like linear kernel, polynomial, RBF, and sigmoid that transfer data into higher dimension. If you are not possible to find the best hyperplane in 1D, then you can just separate the data into 2D, and you can directly get the idea how you can find the best hyperplane. Same like if you are not possible to get the best hyperplane in 2D, then you can just split the data into 3D or 4D. So this is the basic use of kernel in SVM. Next question is, what is k nearest neighbor? So k nearest neighbor is the algorithm you can use for regression or classification also. An algorithm that classifies a data point based on the majority class among its k nearest neighbor. Means if you like want to predict the house pricing, so it will take only consider how many neighbor you want to check. Like if you want to check only 5, so it will calculate the house pricing in the only 5 places, nearest 5 places, and taking the average and give you the suggestion, or it's directly give you the suggestion based on the 5. So this is the k nearest neighbor algorithm. So let's see the next question. So next question is, how is the value of k chosen in k nearest neighbor? So you have can choose the k value via the cross validation. Next question is, what is the drawback of KNN? As I already told you, it will take only the whatever value of k you are giving. So it will not the algorithm like training. So it just going to predict. So high computational cost for large data sets. So if you go for the large data set, then it will take the more time for computing the distance, all those things. So this is the drawback of KNN. Next question is, what is the naive Bayes algorithm based on? So naive Bayes theorem. So naive Bayes classifier is based on the Bayes theorem and with the assumption of independent between predictor. Predictor means whatever value you want to predict. So independence between the predictor means that's the like naive assumption, because in the feature space every feature will not be like independent of each other. If you go in the real life data sets, like if you want to like house prediction, then it will depend on the multiple features, and some features are correlated to each other. So next question is, what is the type of naive Bayes classifier? So different type of naive Bayes classifier. One is the Gaussian naive Bayes, multinomial naive Bayes, and the Bernoulli naive Bayes. So basically Gaussian naive Bayes is used for continuous data, and multinomial naive Bayes is used for discrete data, and the Bernoulli naive Bayes is used for binary data. Next question is, why is naive Bayes considered naive? So I already told you naive assumption, because it assumes that all features are independent, which is not correct in the real world data set. So this is the naive assumption in the naive Bayes algorithm. Next question is, how is the performance of a regression model typically evaluated? So basically regression model is evaluated based on the R2 score, mean square error, root mean square error, or unbiased root mean square error. So all those the basic metrics in which you evaluate your model performance. Next question is unsupervised. Next question is related to based on unsupervised learning algorithm. So basically in the supervised learning algorithm, you have a target value and you have the labels, like whatever you want to predict based on the labels. In this unsupervised learning algorithm, you doesn't have the labels. So the first question is, what is k-mean clustering? So basically k-mean clustering, an algorithm that partition data into k distinct cluster based on similarity. So, based on the similarity, an algorithm that partition data into k distinct cluster based on similarity. K mean clustering basically use the distance metric, even Euclidean distance, Manhattan distance, any one distance you can use, and it will calculate the distance between the point, and based on how many cluster you want to perform, it will calculate the centroid, and after calculating the centroid, it will set the partition of data into that parts of the k, whatever you want to, like 5 parts, 6 parts. So that. Next question is, how does k mean clustering work? So by iteratively assign data points to the nearest centroid and updating the centroid. So k-mean clustering work basically assign data point to nearest centroid. I already told you it will calculate the distance, and after calculating distance, it will assign the data point to nearest centroid, and after that updating the centroid again and again. So that's the k-mean clustering work. Next question is, how do you choose the value of k in the k-mean? So this is the good question. So basically for using the k value in the k-mean algorithm, you just use ALGO method. ALGO method is the basically the graph between the k value and WCSS. And next is the slot score. You can use the slot score also and gap statics also. Next question is, what is hierarchical clustering? So what is the hierarchical clustering? So an algorithm that build a tree of clusters using the bottom up or top down approach. If you are using bottom up approach, then we call this agglomerative clustering. And if you are using top down approach, then we call this hierarchical clustering. So same thing here is writing as, what is the agglomerative clustering? A bottom up approach where each data point start its own cluster, and after merging it iteratively, and it will build the top bottom up approach. And next is the, what is the divisive hierarchical clustering? Is top down approach where all data points start with the one cluster and is split iteratively. Next question is, what is the DB scan? A density-based clustering algorithm that group closely packed point and mark outlier. So basically, DB scan is a good technique for marking the outlier, because in the k-mean clustering, it's think like every cluster is like spherical shape, and in the DB scan, it's not like the spherical shape. It could be anything, but it's how this is work. For the DB scan, you just have to use the epsilon distance and the minimum sample point. It will basically use the technique like core point, outlier, all those things, minimum point. So what are the key parameter of DB scan? So basically the key parameter of DB scan is epsilon and minimum number of points, minimum point, whatever you want to take those. Based on the number you select the epsilon or minimum point, it will give the value like core point, water point, and noise point. Core point is basically in your circle, how many number of point you decided it enter the circle, and if when you will say the water point, if number of point is less than whatever point you select, but one of the core point is enter in your circle. Noise point, when you make the circle and none of the core point enter in your circle. So basically that was the idea for the DB scan algorithm. Next question is, what is the principal component analysis? Principal component analysis is called as PCA. This is the dimensional reduction technique that transform data into new set of variables. Basically, by using this technique, you can see the a good overview of your data, how your data is looks like, and for making the PCs and how this will work, you just take the snapshot where is your data is like highly variate, and take the snapshot of data and it will present to directly to you. So basically this method is used for principal component analysis. We will see how these all algorithm get the good idea after taking the quick short notes. Next question is, what principal component analysis PCA? What is principal component analysis? Means, what is meaning of that? I already told you, the dimensional reduction technique that transform data into new set of variables. Next question is, how does PCA reduce dimensionality? So by projecting data onto a direction of maximum variance. I already told you, by projecting data into direction of maximum variance and give you a snapshot of your data. Next question is, what is the principal component? What is meaning by PC? PC means principal components. So let's see. A linear combination of original variable that capture maximum variance. So this is the good question. A linear combination of original variable that captures maximum variance. Next question is, what is the main advantage of PCA? So basically the main advantage, it reduces the complexity of data while preserving its variance. If you are going to fit the models, and if you don't want to make the model like very complex, then you can just take the PCs and you can build your model according to those PCs also. It will give you the equally good R2 score or like accuracy based on your data. Next question is, how do you determine the number of principal component to keep in PCA? So how you determine number of principal component to keep in PCA? How many you have to PCA principal component you want, like 2, 3, 4. So by analyzing the explained variance ratio. So for this, how many PCs to want? By analyzing the explained variance ratio. Next question is, what is the ELBO method in k-means? I already told you k-means. A technique determine the optimal number of cluster by plotting the WCSS. WCSS is within cluster sum of squares. One side is k, the value of k, and next side is WCSS within cluster sum of square. Next question is, what is dendrogram in hierarchical clustering? We already make a dendrogram. So what is the dendrogram? A tree-like dendrogram that show arrangement of the cluster. A tree-like diagram that show the arrangement of cluster. Like first it will like go bottom and so is the tree-like diagram. Next question is, what is the slot score? I already told you the slot score. So slot score is a measure of how similar an object to its own cluster. So this is a very good question. What is the slot score? A measure of how similar an object to its own cluster compared to other clusters. Mean it will compare every point to its own cluster in comparison to other cluster. Next question is, what are the advantage of DB scan over k-mean? So a ability to find arbitrary shape. I already told you k-mean think like every data point is have the spherical shape, but in the real world data, every cluster doesn't face the that type of shape. So DB scan is handle the noise point also. So the ability to find arbitrary shape cluster and handle noise very well. So this is the advantage of DB scan over k-means. Next question is, what selecting the epsilon distance and minimum number of core point, minimum number of point is very tricky in the DB scan. So this is the like you cannot find like very much. The next question is, how do you handle high dimensional data in clustering? So if your data is very high, if you want to cluster all those things, then it will take too much time. So how do you handle the dimensional reduction, high dimensional data in clustering? So for handling high dimensional data in clustering, why using dimensional reduction technique like PCA before clustering, you can just you already have some data points. Data points means you already have the features, but you don't have the target variable. So you just take the PCs, and after taking the PCs, you can just make the cluster. So it will give you the good cluster, and after that you can just translate all those things. Next question is what is the gap statistics? So gap statistics a method for determining the optimal number of cluster by comparing the total within intra-cluster variation. So for calculating the intra-cluster variation, we use the gap statistics algorithm like method. Next question is what is the main challenge in using k-mean clustering? So using the k-mean clustering, the right value of k is choosing like you can say like the main challenges. If you choose the right value of k, then it will give you the based on the cluster, based on the value of k. If you want to choose 4, then it will give you the 4 cluster. If you choose the 2, then it will give you the 2 cluster. But choosing the value of k by using the LO method, sometime LO method is not good for choosing the value of k. So it is the main challenge in using k-mean clustering. The right value of k ensuring the cluster are well separated. After making the cluster, if you want to see if cluster is good or not, then you can use the slot score. If your slot score is like between 7 to 8 or 6 to 8, then you can see your cluster is good or well separated. Now let's see the question based on assemble learning algorithm. So first question is what is the bagging? So basically bagging an assemble method that reduce variance by averaging prediction from multiple models. Model could be anything like tree, decision tree, SBM, any one of the model you can use in the bagging. And after training on different subset of data. So it assemble method that reduce variance. So this is the question in the bagging. What you just want to reduce variance? In the boosting, what you just want to reduce bias? So bagging is an assemble method that reduce variance by averaging prediction from multiple model train on different subset of data set. Means you are using multiple method with multiple data. So you have data, you just make a different subset of data, and you are predicting different models prediction, and you just taking the average of all those things. In the case of regression, you will take the mean average, or you can see like other average, and for the classifier you just use the mode. Next is what is boosting? So boosting is an assemble method that reduce bias by combining weak learners to form a strong learner. First, you just take the weak learner, and after use the technique boosting, and it will give you the strong learner. So boosting is an assemble method that reduce bias by combining weak learner to form a strong learner. Next question is how does bagging work? By generating bootstrap sample and training a model on each sample. So first you generate the bootstrap sample. Bootstrap sample means you just pick randomly sample. Randomly sample means you just pick the features randomly and make the bootstrap sample. And after training the model on each sample. So how does bagging work? Next is how does boosting work? Why training model sequentially? In the boosting, you are just training the model sequence by sequence. So by training model sequentially, each focusing on the error of previous one. If one model is doing error, you just highlight that error and give you the input of the in the other model in the sequence. So how does boosting work? Next question is what is stacking? So an assemble method that combine multiple classifier using a meta classifier. So you just to combine multiple classifier using a meta classifier. This is the method of stacking. Next question is what is the purpose of meta classifier in stacking? So why you use meta classifier in stacking? To learn how to best combine the prediction of base classifier. Means you don't know which base classifier is doing better. So for combining, you just use meta classifier to learn how to best combine the prediction of base classifier. Next question is how does random forest using bagging? So in the random forest is the example of bagging. So here is the question how does random forest using bagging? So interview can ask to you how does random forest use bagging? So by training multiple trees on different bootstrap sample and averaging their prediction. So this is the simple bagging example of random forest. Next question is what are weak learner in boosting? So what is the weak learner in boosting? So model that performs slightly better than random guesses. Random guesses is like just a straight line on 45 degree. So is the model that predict better than the random guess. So this is the weak learner. You can say this is a good question in the interview. What is the weak learner in boosting? So model that performs slightly better than random guess. Next question is what is the main advantage of bagging? So what is the main advantage of bagging? It reduces model variance and help in avoiding overfitting. So if your model variance is less, then you avoiding overfitting. So in the bagging, what you want to do? You just want to reduce the model variance. This is the good question in the interview. What advantage of bagging? You just want to reduce the model variance and help in avoiding overfitting. Next question is what is the main advantage of boosting? So what is the main advantage of boosting? It reduces bias and can improve the performance of weak learner. So in the bagging, you just reduce the variance. In the boosting, you just reduce the bias and can improve the performance of weak models. Next question is what are the popular boosting algorithms? Some of the boosting algorithms are very famous. So one is the AdaBoost, other one is gradient boosting, and next is XGBoost. So these are the some famous algorithm of boosting. Next question is what is the key idea behind stacking? What is the key idea? To compare the strength of different model. I already told you, you don't know which model classifier is doing better or which model is performing better. So you just want to strength of checking which model is performing better. So to combine the strength of different model to improve performance is the key idea behind the stacking. Next question is how does AdaBoost work? So in the AdaBoost algorithm, we will see in the detail, but here is the one line answer. So by adjusting the weight of incorrect classified instance and combining weak classifiers. So by adjusting the weight of incorrectly classified instance. So if one of the value is going like out of the prediction, that you give the high weightage and go and transfer in the into the next classifier. So this is the meaning of AdaBoost however, by adjusting the weight of incorrect classified instance and combining weak classifiers. So next question is, how does gradient boosting differ from AdaBoost? So how does gradient boosting differ from AdaBoost? So gradient boosting optimize a loss function. So gradient boosting optimize a loss function by adding models sequentially. So it will add the model sequentially and after that is optimize the loss function. So this is the basic difference between the AdaBoost and gradient boosting. In the boosting, what are doing? It will take the model and if you are doing not doing good, then it will implement the bait for those penalty and give into the and transfer into the next classifier. But in the gradient boosting, it will optimize the optimizer. Gradient boosting optimize the loss function by adding model sequentially. So what is the feature importance in random forest? So what is the feature importance in random forest? So what is the mean by feature importance? Because you can directly find out the feature importance in any of the graph model. So what do you mean by feature importance? So basically a feature importance, a measure of impact of each feature on prediction. One by one, it will check the prediction of each feature on the prediction. Similar like Shapley. In the Shapley, it will take the each feature, but using the single feature, it after that will take 2, 3, 4, all the feature combining parts also. That's why Shapley take time for the large data. Shapley is also like explainability technique. Why is model predicting those values? Like in the image data, you use GradCam. Similar like in the tabular data, you can use the Shapley and Lime also, and you can use Shapley and Lime in the image data or video data also. Next question is, what is overfitting in the context of assemble learning? So what do you mean by overfitting in the context of assemble learning? Even in the assemble learning, you want to like model is not good for overfitting. So when a model learn the noise in the training data instead of actual pattern, then you can say your model is overfit. Like if you get in the 99% accuracy, all those things. So it's mean your model is like learning from the noise also. So next question is, how do you prevent overfitting in boosting? So how do you prevent boosting in the boosting? So you, by using technique like regularization, you can use L1, L2 regularization. You can use early stopping and learning rate adjustment also. So you can use these technique in the boosting algorithm. If you are like using XGBoost, all those things. If you are getting like 96, 99%, if you have doubt your model accuracy is too much high, then you can use like regularization technique, early stopping, and learning rate adjustment also. Next is, what is the out of bag error in the bagging? What do you mean by out of bag error? You know error, but what is the mean by out of bag error in bagging? So an estimate of the model prediction error using data not including in bootstrap sample means that data point you are using which is not including in your bootstrap sample. So that's the meaning of out of bag error in bagging. An estimate of model prediction error using data not including in bootstrap samples. Next is, what is the role of learning rate in boosting? It controls the contribution of each weak learner to the final model. So the simple mean of learning rate is it controls the contribution of each weak learner, how much it will contribute for the final model. Next question is, how do you evaluate the performance of assemble model? For any assemble model, you just use the cross validation and accuracy, precision, recall, F1 score, AUC, RUC, and after that you just evaluate your model is performing good or bad. So this is the question related to the machine learning, and now we will go through the deep learning models. 100 questions, not 100%, obviously remaining 40 questions. So this is the deep learning algorithm related question. So let's get started. If you wanted to take this PPT, you can comment in the comment box. I will pin a link in the comment box where you can download this PPT.